vector databases. So what is a vector database? A vector database is a database that is able to, or knows how to work with a vector. A vector is just like what you learned in math in high school. It has direction, it has multiple points of virtual space. I would call it virtual space because what we think of as vectors have 3 dimensions. Mm-hmm. These have thousands of dimensions. And so it's just, you can't really conceptualize what it is. Just know that it has direction and you can compare it to other vectors. And the way you create the vectors are these things you keep hearing about, LLMs. They're one of the engines, one of the models is basically its sole job is to create embeddings. So it's basically a subset of what the LLMs do is they, like when you ask it a question, it tries to find relative information that it knows about. That the way that you can manifest that outside of the LLM is this vector. So it is a way of comparing one sentence to another in terms of meaning. So like if you say red dog and create that vector, a vector based on red dog, you will have one vector. You have brown chihuahua, you'll have a second vector which will be very similar to red dog, which is, you can create another vector. You can imagine a green toad is not, it will have less similarity when you do the computational comparison. So that is the essence of a vector. And so what you do is AWS has a service called Bedrock. What Bedrock is you tell it what model you want to use. It has a list of models that it supports. And you say, here is the model I want, and here are the things that I want you to do with it. It's basically setting up an API to an LLM. And so you say, I want the AWS Titan text embedding model. And then you just specify that in your call and a payload. The payload is specific to that particular LLM. And so they have all the documentation on how you supply information. But what you get back then is that vector. It is purely a vector. It is the only difference from one vector to another is length. I mean, they're all just arrays of floats. So you get that back. You can then store it in this vector database, and there are different ways you can compare it. But it, in essence, is just like doing any other comparison, greater than, less than. It is cosine similarity is what you'll usually find. So you say, here is my search term. I have turned it into a vector where this vector is similar in terms of cosine similarity, and you get back a top X. You could always return all of the results because they all have some degree of similarity. You have constraints that are more standard, like you could always do a top X. Well, that is just kind of the default when you're querying against the Weaviate database. By default, I think it gives you the top 100 of whatever you give it based on this vector, and it gives you the top 100 if there are 100 results to give. I can show you the code and what this all looks like.
So basically, you have 2 vectors and you compare them by the dot product, essentially.
Yeah. Yes.
Okay.
Yeah. So cosine similarity is a function. You'd say vector 1, vector 2, and it gives you a range. Typically, it depends on the context, but it's typically from -1 to 1. Closer to 1, the more similar.
Where does the semantic meaning of brown versus red or dog versus chihuahua come in?
That's all in the LLM. That is what the LLM does. It knows meaning based on all of the things that it's trained on. It's just been a history of people going in and saying, yes, these are similar, no, those aren't.
Okay.
And from all of that knowledge, all of that training, it has basically weights of this context has this value, or it creates what it knows about for that sentence in turns it into a vector.
And that correspondingly is how it gets from what your tokens are to the floats.
Yeah. It's important that one embedding model will not create the same vector as another. So if you use one embedding model to index all of your content in your vector database, you have to use that same model to create a vector to search it. I'll show you what I'm going through.
I got to tell you that word embedding, I tried to find an explanation as to where that word came from. I really kind of struggled that.
Yeah, it's kind of an odd usage for sure.
And it seems like, check me on this, what you're getting is it's the transformation of how your source data gets like embedded in a vector space.
Yes.
I think close?
I think that is about as close to a meaning as I've found. Yes.
I haven't had an opportunity to ask a human that. Thank you.
Yeah, no, it does seem as an odd usage of the term, but yes, I think that is what the intention is.
So it's like a mapping from the input data to a flow vector, and that depends on the embedding, like you said, but also like weighting and things. There's probably like a lot of settings you can tweak.
Not necessarily. That's kind of the beauty of LLMs is it's opinionated.
Okay.
So dog is dog. And so you will get the same vector of the word dog, no matter how you ask it. If you pass the word dog twice, you will get the same vector. And there isn't really parameters you can tweak to get a different vector. The way you get a different vector is the context of your sentence. How are you using dog in that sentence? And so the vector is the overall meaning of the full sentence. So what's interesting is like, if you want to index data, it's not really going to work the way you think it's going to work. You have to give it context. So you can't just throw a CSV at a vector because it has no meaning. There's no semantic meaning. It's like speaking a CSV to your neighbor. I don't know what you're talking about.
So you said you have to tokenize it.
Well, you have to tokenize it, but you also have to turn it into sentences. So one of the last project I was working on, still working on, we are taking text and asking what are the skills that are being discussed in this text. And so we pull out the skills, and our vector is those skills. But if you just simply pass it a list of skills, those words can have many different meanings. So to have networking, the word networking, you can imagine like people, technology, all sorts of different meanings that it could have. And so to give it kind of semantic meaning, you say the list of technical skills associated to this text are, and then list them. That gives it meaning, gives that list of words meaning. And so then when you're searching that, you can give it a list of skills, but you still then in the embedding that you create to search have to do the same thing. So when, like, if you want to look for text blocks that have been indexed that have technical networking capability, you don't want to just create an embedding based on networking. You want to create an embedding that says, I'm looking for technical networking skills. And so that it's really the full semantic meaning. And just like as I'm sure you played around with ChatGPT, the more specific you are, the more likely you are to get an answer that is more meaningful, because it has more to go off of, more context.
So it'd be like if you tried passing in just the word like typing or something.
Yes.
It could mean, typing on the keyboard, or it could mean like typing in like a
code wise, yes. Absolutely.
Which is ambiguous.
Right. Yeah. The more specificity you have, the more likely it is to be useful, the result to be useful to you. So what we have for infrastructure in here, and start with that. Here. We have 2 lambdas. So an indexing lambda, this is attached to an S3 bucket, and the S3 bucket is basically just like a file. You can think of it like a file share, and you can attach triggers. So when a file is uploaded, it can trigger this indexing lambda. And so the indexing lambda would then go chunk those, read the files, chunk them up, vectorize them, save them into the database. And then we have this Weaviate lambda, which queries the database. So I think this is a good summation of the things that happen. So in a vector database, there is what you would normally think of as a table. At least in Weaviate land, is a domain. And so you have a domain is equivalent to a table, and a domain can have a vector associated to it. So each record has a vector. This is a kind of a new age database, and it is you can have objects. It's kind of object oriented. It has it's closer to a graph than it is a relational database, but it's neither. Like it has Weaviate has cross references that are similar to foreign keys, but there's no referential integrity. But you can still do joins and queries that follow those cross references. So that's what this domain is. This is the here we have the Bedrock client, and we're saying use the model Titan text embed, and the input is really just here's my sentence, and I need to format it in this way for Titan text embed. And so what I get out of that is the embedding that is the vector. Well, it's a response that has the vector in it. The body is the vector.
All right, so you've got your vector database that has been pre-populated by other data that you ran through the model that's now stored in the vector.
This is
your search.
Yes.
It's not a query.
Yes. Query is not insert. Yes. Yes.
So the model is this thing that sits over here, this appliance that you throw data at it, and the vector database sits separately, but you interact with the vector database, but everything that's in there or in the queries, it had to have been run through the model. Yes.
Right? And there's also Weaviate in particular has the ability to interact with a Titan an embedding model directly, but you have less control over it. So you have more control doing it this way. You have over like how you construct the sentence that is the semantic thing that you pass to Titan text. So yes, then you have this class name same as domain. Sorry, there's lots of different things call these things differently. So we're in kind of a very new territory for a lot of companies. I think that there will be over time standards that develop, but sometimes a domain is called a class. So, and then the properties are the columns that you want returned. This additional is metadata. Certainty is how certain is it? How close is that vector? So that is that -1 to 1 value. And then you say near, vector near, that's saying here's my vector that I'm searching on, and a similarity threshold. How similar should these results be? And the query limit. Especially important if you want anything more than 100 results. It's funny. There's a lot of interest in doing that right there, and the more people know that, it's not rocket science. This is going to be very widely used. It's like the next relational database. It is going to be another ancillary database, just like NoSQL isn't going away anytime. This is going to be another thing, another type of data store. I have also worked with PG Vector. So there is an extension to Postgres that incorporates vectors. And it works pretty much the same way, but it's not as performant. However, Weaviate was built is very fast. Although we are looking at OpenSearch. OpenSearch also has a vector capability. It is open. Weaviate is a product. And so we're investigating using OpenSearch. This is the essence of searching a vector database.
OpenSearch is Solar, right?
Solar.
Solar 9 has vector search too.
Okay. Yes, it is. It's that same text embed.
Yeah.
It's the meaning. Turning that words into some kind of meaningful vector embedding, what have you. I have dabbled in OpenSearch a little bit. It is very new to me though. So I don't know how much anybody does with infrastructure as code, but I'm a little rusty on my SAM and CloudFormation because I've been using CDK for so long. CDK actually allows you to write real code as infrastructure as code. But SAM is still, I still use SAM for local execution of my CloudFormation templates.
When you say real code, you mean not a DSL?
Correct. Not YAML. But and you can use TypeScript, Python, C#, Go. Those are the big ones.
Yeah, I've been using Terraform.
Yeah, we the challenge that we have with Terraform, we use it, but serverless applications. It's like local execution. The local stack still doesn't do quite enough. Being able to use SAM to locally execute the lambdas is huge. I know that they have starting to support Terraform in SAM though. So really, that's really the big reason why we stick with CloudFormation and CDK is SAM.
Is SAM a big local cloud?
No, it just creates the container that it mimics really just Lambda,
Sure.
but you can also pass it your IAM context very easily. And so you just tell it, run as this profile, and it has that access. And so usually the way we operate is you deploy your baseline infrastructure, you get your baseline infrastructure deployed, and then you start iterating on your lambdas that interact with your baseline infrastructure. I shall show the indexing. So there's a lot of stuff going on in here that is largely noise for our purposes. So what we use is LangChain. What LangChain ends up being is a series of libraries that help with text processing. It helps with the chunking of that text to be able to feed it into something like Titan text. And so it creates smaller chunks, but it has awareness of some semantic, it has some semantic awareness. And so this text splitter, really the only thing that we're using in here.
Is that similar to NLTP?
It's less NLTPing.
Okay.
It's really for document processing.
Okay.
And getting the documents into a form that is consumable by the LLM.
Okay.
So you can see here, we're saying chunk size 200, overlap 20. What that means is 200 tokens with 20 overlap. So it takes your text document, splits it up into 20, and with 200 token overlap between each for each of the sections. And that is what is tokenized for your vector database. So we take each of these, we create an embedding, we save it as a record. And that, so this is the extent of LangChain in here, these two statements.
So your input data, that's just natural language text.
Yes.
Okay.
Yeah.
But you could use other things. For example, like if you wanted to do like a sequence of a genome or something.
Yes, as long the trick is, does the embedding have the knowledge of what that means?
So there's probably a specific embedding that you'd want to use for that.
Yes. Yeah. So it would all be driven by your, like Titan text does human language text.
Okay.
But I'm pretty sure that it doesn't understand genome sequencing.
Fair.
Is the overlap like for kind of just it asks the obvious. So you have this big long chain of tokens, it's easier if you do it in smaller vectors, and if your search vector happens to overlap, it leverages its efficiency.
And it's also, the LLMs have limited capacity as well. So there is only so much data you can pass to it. So yes, have more fine-grained search capability of your document, and you're not throwing an error by throwing too much data at the LLM. And most of the rest of this file is dealing with different file formats, extracting the text out of a PDF. Actually, I think PDF reader, no, Titan LangChain also has a PDF reader. I think we're not using the LangChain PDF reader here, though. PyPDF. Yep. But yeah, so in here, the entry point of this is down here. I started trying to modularize it, but really you have your event comes through, and this event will be what file, the information about which files just changed. Not the files themselves, but just where to find them. And so, and we have this set up so it could either come off of a SQSQ or directly off of S3. So here we're just reading the location of the S3 file, and then we're saying index it. And so that is what all this is. We're indexing the S3 file. In here, we're downloading it and then running it through this local indexing, which is really which type are you. If you're not a supported type, throw an error, and make sure that this table, the schema, is created for your domain, and then index. So I also, in case you want to index the same file more than once, you want to remove the current embeddings, but it's not as, because you're taking a file and making multiple, you have to delete multiple records, and you have to track which files are from which chunks are from which. So that's something that we do explicitly. So like here, show you so this is the basic schema that we use: text, bucket, key. And so our primary domain will generally have at least these three, at least in this context. We'll have at least these three columns, and the vector. You don't have, in Weaviate, you don't have to specify the vector column. It's just always there.
These are metadata.
This is your columns. The vector is actually considered the metadata. And so, and also the ID, each row has an auto-generated ID, which is also considered metadata.
What do you mean the vector is the metadata? Isn't it the what you want to store in the database?
It is. It's part of what is stored in the database, but it is computed from some of this data. It is a representation of this data. It's essentially redundant.
So the property text, that is the
chunk.
It's not just a reference,
right?
To where it came from.
Yes, that is the chunk. That is the 200 token chunk. So yeah,
so maybe for for a relational database metaphor, those columns are like the columns on your table. Your vector is like an index on it.
Essentially, and really, like with PG vector, the vector is literally a column in that table that you just store that vector in addition to your other columns. So indexing, Weaviate is GraphQL API. You could also interact with Weaviate just through HTTP. Generate, let's see, here, my generating the embedding just before saving it. I'm creating the chunk, the string for embedding based on the object, and then the embedding. And so getting back my embedding and saving it. This is saving the object. The data object is a JSON object that represents those three columns that you saw. And then the class name is the domain, the table name, however you want to think about it. Vector, obviously the embedding, and UUID. You can specify the row ID. Useful if you wanted to turn around and then update that row. But that is right there, indexing into Weaviate. Like I said, a lot of this is not rocket science. It's just knowing where the pieces are. We also had this else is essentially the same thing, but assuming that Weaviate is going to handle the embedding. Seeing as my template is being a pain in the butt, let's try something else. So I have Weaviate stood up, and Weaviate is an AWS marketplace offering. So, and you're able to just go in and set it up. I hope you got useful information.
Yeah, it was quite informative.
Yeah, is there anything that you'd like to take a closer look at while we're here?
You want to talk more about Bedrock?
Sure, there's actually not that much to talk about. It behaves a lot like ChatGPT. The way that I have understood it and the way I have interacted with it is the way that it has memory is you just keep passing it an ever-growing block of the conversation. So you just keep passing it the full conversation. So, and the responses you get back are just like you get in the web. So you have, if you're using it in a programmatic sense, you have to do an awful lot of cleansing. Oftentimes we're retrieving the list of skills out of the block that is passed. We're saying return a JSON list of the technical skills that you find in this block. And it's still, so we're using Claude. When we're not doing embeddings, we're using Claude as the large language model to do actual analysis like that. And it insists on putting markdown comments around the JSON in the response, and usually some kind of descriptive text before it, saying what it's returning, because it's designed to speak to humans. So you're looking for the first curly brace and the last curly brace and pulling everything in between and hoping that there isn't a strange collection of things that are returning. But that is really the essence of working with an LLM, at least in my limited experience. Though we are certainly doing much more with them. Specifying Claude versus Titan Text is really just a different model ID and the JSON structure that you pass it. When you're dealing with here, actually, I can show.
So if I were to try to do this, am I going to get charged like
There are
$100 million?
no. It's for the playing around with it. It's not a ton. It's when you, because usually what you want to do this is in production is volume. You're going to use this a lot. And then, yes, you are going to incur spend. I'm not as well versed on the actual cost structure, but it's not overwhelming, because there's lots of people who are like, we have one customer who we did basically a chatbot for interacting with their documentation, asking questions about their documentation that they offer their clients. And that is just something that they are offering to their clients now. And it isn't an unduly burdened cost-wise. So there is definitely some cost to it, but
Probably depends on like how much data.
how many, it's per request. It's per, each request to Bedrock has a cost to it, but it's not huge unless you're talking about millions of requests.
Okay.
Cohere is another good one. Cohere is good for more technical, like if you're doing things like in the medical realm or something that is technical jargon, then whereas Claude does well with human chatbot type things. Usually when I submit these for getting access to Claude, it's done within minutes. I almost think that this is just a form to limit the flow of requests. Yeah, it immediately comes. Yeah, access granted, in progress. Yeah, I've never seen these be in progress for more than like 15 minutes. I can't imagine that there's somebody actually approving them in 15 minutes. But yeah, this is a step that you need to take to enable access to the different models. And let's see here.
It's provisioning.
Yeah. And you can see here, example of the API request. thought there was. A better documentation of the models. Here we go. I think this is what I was looking for. Yeah, I guess this is thing. So yeah, you can see here Anthropic Claude 2 content type accept, and then this body will have a prompt, and the prompt is the Anthropic uses these key tokens of 2 character returns human : as your request. It actually the model actually looks for that, and at the end uh 2 character returns assistant : and it actually shows it up here, I believe. Not seeing a good spelling out of that, but and then you can see here at the end max tokens to sample. this is actually an interesting part. This max tokens to sample is actually the response. How big is the response that you want? So how many tokens to return in the response? They all have that as a property of the request, and they all call it something different, and it is super confusing. Like in my mind, max tokens to sample sounds like something you'd be doing on the input.
Exactly. Yeah.
But what it actually means is you're sampling out of the output. So because it could go on for ages of how much it gives in response.
Right.
So you are saying, just give me the first 2,000 tokens.
It's like a lorem ipsum generator.
Yeah, sort of. Yes. Yes.
The first 2,000 words.
And then you also have the temperature, top K, top P. I don't understand these as much, but they are model parameters. Yes. So this we were talking before about controlling them parameters. There are these, but I don't think. Let me see. Do they have these for the text embeddings? So might make a liar out of me. Text. It does. Okay. So it doesn't, they almost all have a slightly different set of parameters that you can pass, but Titan Text Express, I guess Titan Text Express is the thing. So yes, you have temperature, top P, length.
So I'm trying to put the things together. So you showed us that the database, what's
Weaviate.
Yep. That stores the vectors. And how do you actually put those models?
They're 2 really separate things. Beyond the Titan text embedding, creating the vector, there's really not much interaction that Weaviate would have with the LLM.
Okay.
It's really the only thing that the vector database cares about is, how do I create my vector?
And how does it do?
And the way that I showed was using the Titan text model you pass it the string, and instead of coming back with a human readable response, it tells you its understanding of that statement in a vector.
So you're talking to the model and the model's talking to the database.
No, we actually get back the response and pass it along to the database.
Okay.
So
You do the link.
Yes,
between
yeah. Yeah, you can, Weaviate could do that for you, but you lose some control over how the string is passed to Titan text.
Okay.
As we have discussed, semantics are important.
And here you want to store the vectors in the database for what reason exactly?
To be able to compare meaning of one sentence to another. So if you want to find the resumes that talk about networking experience, you want to the vector will get you resumes that have networking experience if you ask that question.
And that's why the columns are important. Because when you index the data into the vector database and you put those extra columns on there, when you then query it with your search query, you get back the data.
And the columns actually don't matter.
That's not the return value.
Well, it's the return value, but the vector is driven solely by the string that's passed to create the vector.
Yeah.
But then, yes, once you have a similar vector,
yeah.
The columns are then important to you.
Yes, yeah. Just getting back a
vector is not going to be helpful.
Yeah.
Yes,
you have to then translate that back. But if you've stored the actual source data with it,
yeah.
So tell me again, how do you change your sentences into vectors? Or
you pass it to the Bedrock. You pass it to a very specific model, LLM model.
So like that. Like
yes, the Titan text.
Okay.
The Titan text returns.
Can you scroll down? Yeah. Is it? Oh, that's the API request. Sorry.
Yeah, that's the API request.
And so, okay, you send that request and you get a vector back.
Yeah. You get out of this, instead of a textual response, you get a vector.
Okay, here the response is in text.
Yeah,
right? So,
do
you have an example?
Maybe open-ended check. It actually looks like they don't have an example of the vector. It looks like here they're using the Titan text as more like the conversational model.
Yeah. Okay. So you wouldn't be using this one specifically.
Yeah. I wonder if I'm actually, now that I think about it, I don't think I've ever actually looked closely at the Titan text response. I bet it also has a text response in addition to the embedding. Yeah, no, it's super fascinating, all the different potential applications, because what we've found is useful is extracting meaning from well-formed data. It's less about actually creating something than understanding something, than like summarizing to get nuggets of information out of. Less useful if you are trying to go from nothing to something.
Right. So Titan is basically an LLM
Yes.
that instead of returning a single response, returns a set of vectors that basically encompasses all the potential responses.
Yes.
Right.
Well, I think it's less about responding to a question than defining the question.
Right.
Yeah, it creates a vector representation of the question.
Of how it understands the question.
Okay.
Instead of actually answering the question. Which is the first step that it needs to do to answer the question.
Yeah.
They're just exposing that.
Yeah, you're feeding into the model your collection of questions and answers.
Yeah.
And then when questions come along, you feed those into the model, you get the vector back, you then compare that with the questions you got, and you got the answers attached to that.
Yeah. Essentially, yes.
Are there any models that you know of that are good at something that's not language, like say you've got a table in a database with columns. There's some of them are numeric, some of them are strings. What could you vectorize those rows? Is there a language model that would? I mean, you have to build one, like
Right.
that you have like properties, real estate.
Yeah.
You've got number of bedrooms, number of square feet. Do they have a garage? Do they have a pool? And you want to find properties that are close to, you know,
That
you got a whole bunch of
similarly,
properties and like
yeah.
what's close to this one.
Yeah. No, the structured data is actually challenging because you have like the it's actually easier to train. It seems though, and I'm totally stepping out of my realm of expertise right at the moment, but from my observation, it's easier to take the wealth of human textual knowledge and train on that than it is to try to define this well-defined set of data and give it context.
I think it would be easier to convert that table
Yes.
into sentences.
Yeah.
Like this house has 2
Yeah.
bedrooms.
Yes, absolutely.
Or
Yes.
even into numbers yourself.
Yeah.
And then you come up with your own.
Yeah, your
comparative
own
model, and
vectors.
then you vector based
Yes.
on that.
Yes, yeah, creating
Yeah.
some kind of an algorithm. Yes,
And that's the trick of the whole.
exactly.
semantic
You
web.
don't have, you have a universal algorithm.
What the AI didn't get anywhere with the top-down modeling of let's model the universe and
Right.
figure out what we're getting is we're throwing massive amounts of human communication at it, and it's approximating language and meaning.
Yeah.
And somehow is successful.
Yeah.
But its ability to extract meaning is largely based on the amount of samples that you can supply, right?
Yes.
So if you could get probably 100,000 samples of houses, it should probably be able to extract the meaning from it, right?
Yeah. Yes, and it's about that it all comes back to semantics and how you define those semantics.
Right.
The way that
you
the
label
semantic.
it.
What's that?
Oh, sorry, how you
It's okay.
label it?
Yes.
Yeah.
And it's how the models were trained.
Right.
We had a hilarious thing. Literally today, one of my coworkers fed a large SQL query into ChatGPT because it was slow. And it came back with a suggestion that the rest of us are like, that could work. And
Nice.
We just kind of shocked that
and it's definitely a thing. Like that's what I'm saying. Like if you want a nugget of information out of this block of text or this volume of text, it's great. I also use it for I've recently been working with Intuit's API, which is awful. They give you JSON examples of the responses. And there is a Node.js library, but it doesn't define any of the models as types. And so I've been taking the JSON examples, feeding it to ChatGPT and say, make me a model for this JSON. Make me a type for this JSON. That's great. It works great.
I'm pretty close to having feeding some Terraform questions in one of these things.
Yeah.
I need some Terraform scripts that let me make something in Azure.
Yep. No, and I am definitely not opposed to Terraform. It has it is kind of halfway in between a real programming language and YAML, because you have like the loops and map variables, and I've been very successful with it. I just struggle with like building like a Lambda that builds that pulls its dependencies and all that kind of fun stuff.
I had this very conversation earlier this week, like how can we actually deploy Lambdas in a way that is sane? And like I don't want them in the Terraform repository and like that.
Yeah. Yep. It has to be like, because it's, they're integrally linked.
Well, the solution we did kind of agree on is maybe a CI/CD thing that
Mhm.
ultimately does Terraform, but it's like the maybe, or just using the AWS SDK,
Mhm.
but
Yeah.
it's just weird.
Yeah, it fits better with CloudFormation. So,
Code is infrastructure. Lambdas are code is infrastructure. As opposed to infrastructure is code.
yes. Yes. And yeah, and what I'm doing is primarily serverless implementations. And so I have done sophisticated Terraform applications, but yeah, as soon as you get into Lambdas, you're in kind of fish out of water.
Is that because you need to like set up the environment?
It's managing application dependencies, because like when you're in developing an application, you have a requirements or dependencies definition that goes along with your application, but you don't want to have to save all of those dependencies in the source control. You just want to have that definition, and then when you go to deploy it, it pulls down all those dependencies, or it has, and hopefully you have well defined your dependencies so that it pulls down a very specific dependency, but you want to do that when you deploy it, not
After.
not before. You don't want to check those into source control.
So you're talking about like a requirements
Yes.
text file. You're saying you don't want to check.
You
that?
want only the requirements,
The
not
text, not the modules.
right, the text
Right.
that lists what you need to download, and that's it in source control.
Have you done a container, a containerized?
I do them all the time.
Yeah.
Yeah. And when it builds, it pulls down all the dependencies. Actually, I have that brings me that reminds me. So trying to create a package lock in Python. I've actually come up with some scripts. You have to do it slightly different with Windows than Linux. So PowerShell versus Bash. But I want to show you what I came up with and get people. What's that?
You're not sharing that.
Oh, I'm not sharing that. Thank you. So, pip freeze. They essentially do the same thing, but what these different. Whoa, too much. So I install a very particular version of Python that I want as a virtual, into my environment, set it as my virtual environment, install my requirements, and then create a frozen text from that. And so I go through all of these steps just to create a frozen requirements that I use for deployment.
So why don't you use pip freeze?
I have that pip list could be pip freeze as well. This I had read a couple of things that said that this is actually has more of the dependencies than a pip freeze literally takes directly the things you have in your requirements and makes a frozen no
It has more?
I forget why I went.
I read that too.
Yeah.
And I was like, well, when I do freeze, I have the whole thing, not just the ones that I.
Yeah. So that's why I did that. I was it did produce a different list, which seemed to be a little bit bigger.
But doing this with an environment that you bootstrap and not on a server certainly does give you the things that you deliberately install. That
right. So
you use that as the thing to build the things with the specific versions.
Right. So in my Docker file, I only use the frozen list.
Now,
So
That's like a node log file.
yes,
Yeah, right.
yes, I'm creating a lock file.
Yeah, that's cool, because otherwise, like, I go back and forth from putting the version numbers in my requirements file. Sometimes I want them, and then I go in and I
Uh-huh.
periodically clean them all out,
Yep.
and then as we think like, oh no, we can't upgrade the MySQL project, so we have to like put versions on that,
And-
but then.
But I don't put versions on everything in here, but I feel comfortable doing that because I'm producing the frozen.
Yeah, exactly, I see. And then what you deploy is consistent
Yeah.
based on your deployment.
Right, it's
Even though the requirements, the next time you would deploy and start your test QA deployment process, you'd probably start with the requirements.
Right. So anytime the requirements text needs to be updated, I will run these pip freeze to update the frozen list. Yeah, and the PowerShell looks slightly different. You can ignore down below. But it actually, oh, this is old. Oops.
And you're not doing Python -m pip.
Yeah, no, this is an old version. Here, this is. I must not have propagated. I was playing with it in the root. So Pi command in Windows is Windows only, strangely enough, probably just because PyEmp it does not work on Windows. There is a PyEmp for Windows. It is hot garbage. But Pi, you can just specify, as long as you have that version installed on your system, that Pi-311 will run the 311 version of Python. And so I create my virtual environment from a very specific version, just like I did with PyEmp, and then activate pip, requirements install, freeze, deactivate. So very similar, but yeah. I find it strange that this is so challenging to do. Like, why did I have to create this?
I don't know, I remember a time with easy install, and that was absolutely not easy to install. Pip. I walked away from Python for a few years, and I came back and Pip was there. I'm like, oh, this is so much easier.
Yep. There's a new kid on the block too. Supposed to be replacing pip written in Rust. I'm failing on the name, right?
checking with poetry.
No, I don't. That doesn't sound right. But it's something. So there's something vying for Mindshare. Some new app vying for Mindshare now.
Not poetry. Python dependency management.
Oh, poetry.
Oh, sorry.
That's okay. Poetry is a little different.
Okay.
It is a package dependency manager that will replace pip, but it is purpose built for web APIs, I believe. It uses its own flavor of PyProject.toml. PyProject.toml is great, but they started using it before it actually was standardized. UV is the new kid on the block.
Is that spelled out? Like, why are you usually, how's it spelled?
Oh, I'm sorry, I'm not sharing.
It's UV.
So
UV.
just literally
The
UV with two letters.
like ultra.
Yes. There's just different colors.
Yeah, why?
I must have my dark mode on.
Oh, no.
No, I think my system is set for dark mode.
Mine must be too. I got the same color.
Yeah. But yeah, it's supposedly super fast. How it is super fast, I'm seeing is most of what it needs to do is REST requests, downloading of files. There's a magic teleporter.
It's written in Rust.
Yes, yes, everything is going to be written in Rust.
Been Python.
Yes, rewrite Python in
That's the
Rust.
direction we're going with this,
Yes,
right?
yes. Going from C.
It incorporates an actual Ansible, not the Python package, the actual faster than like
Yes.
applications.
Yeah. Oh, that's what I got. Fun stuff.
Yeah.
New,
that's really
new,
good. Thanks.
that's new doors opening for sure.
Yep.
But yeah,
Yeah, it was really nice to see a developer level talk about this because
yeah.
we have a partner organization that was talking about some of these things with Bedrock, and
Mhm.
we have a Chat GPT little application that a different group built for us. Like, I'm a data guy, but I
Yeah.
don't know what these specific pieces
Yeah.
are.
That,
And all I've been
I'm
getting
with
is
you.
the architecture diagrams.
I am not an AAML guy. I'm coming at this from a relational database world.
And even the YouTube videos about it are just as bad.
Oh, yeah.
Like the amount of like inside baseball, just specific
Mhm.
technical jargon. And then I'm like, I spend the entire time Googling words and I still don't understand the context. I'm like,
Yep.
I'm not an idiot. Why is this so
Yeah.
hard to get
Yeah,
in?
I'm
Get into this.
honestly surprised I didn't get more of a turnout.
Yeah.
But we'll do it again, I'm sure.
Yeah, it was very, very interesting.
Cool.
I learned
Awesome.
a lot. for
Awesome.
sure.
Yep.
Next time I'll try to not break my environment. Actually show it to you working.
So I actually have a math background,
Okay.
but it's an undergraduate, so
Okay.
it's not quite at this level,
Mhm.
but it's. Actually, I went for physics.
Alright.
So I did take some like linear algebra and some statistics. But this is like kind of above that for sure.
Cool. And it's like the tooling has made it easy and accessible.
Oh yeah, and then I was playing around with like scikit-learn and stuff. It's like pretty easy to get started.
Yeah.
You say scikit, what?
Scikit-learn, it's a Python library or framework with a bunch of machine learning. It has like algorithms built into it, so it does like linear regression. It does nearest neighbors. If you have like a bunch of data, it also classifies data. So like if you've got like clusters of data, it will, if you give it a data point, it'll say, okay, it belongs to this cluster or this cluster. And it can do a lot more than that. I'm not super familiar with it and I haven't used it in a while, but it's very, very interesting.
That basically the same types of thing as a cosine similarity. Like you can do nearest neighbor within Weaviate as well. But it doesn't give it the cosine similarity gives more the responses that you're looking for.
Yeah, it's basically like all statistics
Yeah.
under the hood.
I was really excited with that movement. I was using R for a little bit and it felt very weird. Like the you were talking about the columnar stuff with the pandas. I was really happy that all that the Python developers apparently had the same reaction to R that I did. Like this, can we just do this with code?
I've seen R a few times, but I've never really tried to dig into it. It just seemed very foreign.
And it's a life boat from SAS.
All right.
So the SAS, the statistical the stats equivalent of Oracle.
Okay.
It's the thing that everybody has to pay for when they were statisticians.
Yeah.
R came along and slowly got to the point where it was good enough to
Yeah.
make everybody like be able to use an open source project, at least the academics.
Yeah. Interesting.
Then for a while, they had wrapped the core of R with Python.
Yeah.
So you could install the R statistical engine and still interact with an API, and then eventually they got all the algorithms.
Okay. Interesting.